Welcome to the Cambrian explosion. All of Earth's history is placed on the geologic time scale. The Cambrian period takes place between 543 and 490 million years ago in the Paleozoic era during the Phanerozoic eon. First, we need to understand the time scale. Eons are marked by approximately 1 billion years. Eras are marked by major events in Earth's history, and the Paleozoic era began with the Cambrian explosion of life and ended with one of the world's largest mass extinctions. Then we get to a period, which is a subdivision of an era, and these are also characterized by major events or mass extinctions or explosions. How did the Cambrian period begin? Well, the beginning of the Cambrian period is marked by the end of one of the worst ice ages. There was also the splitting apart of the supercontinent Rodinia, and we also saw an increase of atmospheric temperatures and a new explosion of life. In the Precambrian, there was a supercontinent Rodinia. Most evidence suggests that it broke apart in the early Cambrian period, but some new evidence suggests that it didn't happen until later in the period. However, for the rest of the presentation, we are going with the most scientific evidence that suggests that it happened in the beginning of the period. As Rodinia broke apart, most of the new continents gravitated to the southern hemisphere.
The supercontinent Rodinia was separated into three main continents. The first of these is Laurentia. This continent was located around the Pleo-equator, and it is assumed that the climate was very warm and tropical. Laurentia has remained mostly intact over millions of years. Because of this, we have access to a large amount of information about the Cambrian period. The second of the three main continents is Baltica. Baltica is very small and had a thin crust. It was made up mostly of shell and sandstone, and the final and largest continent during this time is Gondwana. It reached from the North Pole to the South Pole, so the environments of this continent were drastically different across the continent. Next to Gondwana is a very small continent that over time split from Gondwana. This land mass is called Siberia. We know they were once connected because the sediments of the two land masses are also identical. Now I'll ask a question and give you 15 seconds to come up with an answer. Are you ready? Okay, here we go. What Cambrian continent was modern-day North America once part of? If you guessed Laurentia, you're correct. Laurentia made up modern-day North America and Greenland, while Baltica made up most of Europe and Scandinavia. Gondwana made up the rest of the present-day continents.
Throughout our research, we kept coming across how important the oceans were during this time, so we began to wonder why the oceans were such an important feature during the Cambrian period. All life that existed during this time was present in the oceans. The reason that life flourished was because of oxygenation in the ocean and an increase in temperatures. Initially, the temperature of the ocean was very cold because of the melting of the glaciers, but over time they warmed due to their shallow depths. Although the ocean during this time is considered shallow in comparison to modern times, it did in fact increase in depth by quite a bit in the beginning of the period because of the initial melting of the glaciers.
One of the most important factors during the Cambrian period is not only the increase in temperature, but also the increase in oxygen. This increase of oxygen allowed life to flourish. This increase was most likely due to the release of oxygen through photosynthesis by macroalgae and stromatolites. Stromatolites are microorganisms such as cyanobacteria that are encased inside of rocks. Now for the second question. You'll have 10 seconds to choose your answer. What factor do you think contributed most to the explosion of life we are about to discuss? State what you think is correct and why. I'm in front of the Cambrian explosion part. The beginning of the Cambrian explosion is marked by the end of the world's worst ice age. Scientists believe that this gave life the opportunity to evolve. Temperatures and oxygen also increased throughout the Cambrian period. This gave life another chance to evolve further.
We're at the University of Kansas Natural History Museum at the trilobite exhibit. Trilobites were arthropods that first came to the Earth in the Cambrian period. They were called trilobites because they were three-lobed animals, and if you look at this picture here, it's the axle lobe, which is their body from their head to their tail, and then the left lobe and the right lobe. Many people wonder what the trilobites used or ate to survive. Many scientists suggest that they fed on unearthed burrowing prey and also decaying debris on the ocean floor. While they were preying on these organisms, they were being preyed on by Animal-Icarus. To the left we have a fossil of a claw of an Animal-Icarus, and to the right we have a fossilized trilobite with a piece taken out of it, which many scientists believe was a bite mark of the Animal-Icarus, which suggests that they were predators of the trilobite. There were three main types of trilobites during the Cambrian period. They include the Oleanolus, the Cambriopolys telesto, and the Paradoxidid. All forms of trilobites branched off of the Oleanolus.
In addition to what was shown in the two previous videos, it is also important to emphasize how amazing trilobites were. Due to their developed eyes, they were the first prey to have somewhat of an upper hand when it came to their predator. Also, their hard exoskeletons helped protect them more so than any other prey previously. They also were the first animals to develop jointed legs. All these things show a glimpse into the modern organisms we have today. Because of how amazing trilobites are, all information about them could never be shared in a few short minutes. Now we believe it is important to touch on the predator of the trilobite, the Animal-Icarus. These creatures were huge. They could grow up to 6 feet in size and were the main predator during the Cambrian period. Although the trilobite and Animal-Icarus were the two main species during this time, there were many other organisms as well. They were mostly metazoan phyla with hard parts, such as shells, scales, and spikes, although there were some without. There was the Pacaya, which is an early form of a fish, sponges, hallucigenia, earth-burrowing worms, and plants, which were mostly single-celled algae at this time. There are also brachiopods and many other forms of arthropods. Now we will play a short video and pay close attention to the colors of each animal and what you think their names could possibly be. There will be a question following the video. What organism do you think the blue creature was? You have 10 seconds to determine your answer. If you said Animal-Icarus, you are correct. So what ended the Cambrian period? Most scientists seem to agree that it was the beginning of another ice age that would end this amazing time in history. But time did not stop here. Weeks after the Cambrian marks the beginning of the Ordovician period. Now I'm sure all of you are wondering if there's anywhere you can go to visit that the layers of the Cambrian period are still exposed. So don't worry, there is. There are places in Utah and of course the Grand Canyon. So next time you're passing by either of these locations, make sure you stop by and take a look at the remaining history of the Cambrian period.
The Cambrian explosion, it happened in the sea, in an age of invertebrates, maximum diversity, trying on every kind of body plan. The fossils tell this tale, the dominant type pipes were the trilobites. You can see them in the Burgess Shale. 545 million years ago, to kick off the Paleozoic, we see seashells on the seafloor. Hi, Pagaya, my backbone kin. Oh, Pabinia, how have you been? We don't get to see you anymore. Cambrian explosion. All life is in the ocean. Cambrian explosion.